Research is hard, but your tools should not be. Subthesis.com is the free alternative to expensive software. Whether you need to calculate Cronbach's alpha or organize your field notes, Subthesis has a tool for it. No paywalls and no registration required. Check the link in the description and let's dive into today's lesson. Welcome back to the PM Playbook. Today we confront one of the most uncomfortable realities in project management, estimation. You're asked to predict the future with limited information, then held accountable when reality differs from your prediction. Let's talk about how to do this better. Here's the paradox of project estimation. Estimates are most needed early in the project when we know the least and accuracy is lowest. Those early estimates set expectations that persist throughout the project, even as we learn more. Organizational pressure almost always pushes estimates lower rather than more realistic. Everyone wants to hear the optimistic number, yet we must estimate to proceed. Resources need to be allocated, budgets need to be approved, deadlines need to be set. The challenge is to estimate responsibly in this difficult environment. Estimates go wrong for predictable reasons. Optimism bias causes us to underestimate difficulty. We imagine the happy path where everything goes smoothly. The planning fallacy means we ignore historical data. Even when similar projects took longer than expected, we assume ours will be different. Pressure causes us to tell stakeholders what they want to hear rather than what they need to hear. And hidden work means we miss scope elements that only become visible during execution. Understanding these biases is the first step to counteracting them. Let's explore the major estimation techniques. Different situations call for different approaches, and the best estimates often combine multiple methods. Expert judgment is the most common estimation technique. You ask experienced people what they think. How long will this take? How much will this cost? For routine work that the experts have done before, this can be quite accurate. The challenge is that individual experts carry individual biases. One person always underestimates, another always overestimates. Combine multiple experts and aggregate their estimates for better results. The Delphi Technique, which we'll discuss, formalizes this approach. Analogous estimation uses historical data from similar past projects. You find a comparable project and use its actual results as a baseline for your estimate, then adjust for differences. Your project might be slightly larger or use newer technology or have a less experienced team. Make adjustments accordingly. Analogous estimation is typically more accurate than pure expert judgment because it's grounded in real data, but it requires good historical records. If your organization doesn't track project actuals, this technique isn't available to you. Parametric estimation uses mathematical formulas based on project parameters. Construction uses cost per square foot. Software uses hours per function point or lines of code. Training uses hours per participant per topic. When properly calibrated to your organization and context, parametric models can be highly accurate. The key is validation. The formula must be based on actual data from your environment. A generic industry formula might be wildly wrong for your specific situation. Build and validate your own parametric models over time. Three-point estimation acknowledges uncertainty by generating 3 numbers instead of 1. The optimistic estimate is the best-case scenario. If everything goes perfectly, how fast could this be done? The most likely estimate is your realistic expectation given normal conditions. The pessimistic estimate is the worst reasonable case, not a catastrophic scenario, but a realistic bad outcome. By generating all 3, you explicitly capture the range of uncertainty. This is far more honest than a single-point estimate that implies false precision. The PERT formula from Program Evaluation and Review Technique converts 3-point estimates into a single expected value. Take the optimistic, add 4 times the most likely, add the pessimistic, and divide by 6. This weights the most likely scenario heavily while still accounting for the range. You can also calculate standard deviation to quantify the uncertainty. Standard deviation equals pessimistic minus optimistic divided by 6. This gives you a confidence range. The expected value plus or minus 1 standard deviation covers about 68% of likely outcomes. Bottom-up estimation starts at the work package level. You estimate each work package individually, then roll up the estimates to get the total project estimate. This is typically the most accurate approach because detailed estimates are more reliable than high-level guesses, but it's also the most time-consuming. You need a detailed WBS before you can do bottom-up estimation. For early project phases, when a detailed WBS doesn't exist, you'll need to use other techniques and refine with bottom-up estimation later. The Delphi technique gathers estimates from multiple experts anonymously. Each expert provides their estimate without knowing what others estimated. You compile the results and share them with the group, showing the range and average. Discuss the outliers. Why did someone estimate much higher or lower? They might have information others lack. Then repeat the process. Experts revise their estimates based on the discussion. Continue until the estimates converge. This technique reduces groupthink. Experts aren't pressured to agree with a dominant voice. Estimates are inherently uncertain. The question isn't how to eliminate uncertainty, but how to handle it responsibly. Contingency reserve is extra time or budget set aside for known risks. These are the risks you've identified in your risk register. If a risk materializes, you use contingency to cover the impact. Contingency typically runs 10 to 25% of the base estimate, depending on project risk profile. The project manager controls contingency. They can allocate it when needed without escalating for approval. Contingency is part of the project baseline. It's your buffer against the known unknowns. Management reserve covers the unknown unknowns. These are risks you couldn't have predicted. Management reserve typically adds 5 to 15% above the contingency reserve. Unlike contingency, management reserve is controlled by the sponsor or senior management, not the project manager. To access management reserve, you need formal approval. This prevents it from being consumed by ordinary project pressures. Management reserve acknowledges that some surprises are inevitable and provides a safety net. Novel work that hasn't been done before carries the highest estimation uncertainty. For truly new work, don't pretend you know the answer. Use ranges instead of single-point estimates. Instead of, this will take 6 weeks, say, this will take 4 to 10 weeks depending on what we discover. Plan for discovery and adjustment. Build in checkpoints where you'll reassess the estimate based on what you've learned. Consider doing a proof of concept or spike before committing to a full estimate. A week of exploration can dramatically improve estimate accuracy for novel work. How you communicate estimates matters as much as how you create them. Present ranges rather than single numbers. A range of 8 to 12 weeks is more honest than claiming exactly 10 weeks. Explain the assumptions behind your estimate. If you assumed the vendor would deliver on time, say so. If you assumed 3 senior developers would be available, say so. Describe your confidence level. Are you 50% confident, 80%? And document what could change the estimate, what discoveries would push it higher, what efficiencies might bring it lower. You will face pressure to lower your estimates. Stakeholders want faster, leadership wants cheaper. This pressure is inevitable. Stand firm on realistic numbers. Explain your methodology. Show your data. If the timeline is truly fixed, trade scope for time. What can we remove to meet the date? If nothing can be removed and the date can't move, document the risks. Write it down. Committing to this timeline requires X, Y, and Z to go perfectly. If any of these fail, the project will be delayed. This protects you and ensures stakeholders make informed decisions. Estimates improve as you learn more. Early estimates are rough order of magnitude with wide ranges, perhaps -50 to +100%. As requirements are clarified, you develop budget estimates with tighter ranges, -25 to +75%. As detailed design is complete, you produce definitive estimates with the tightest ranges, -10 to +25%. Communicate which type of estimate you're providing. A rough order of magnitude is appropriate for project selection. Committing resources requires a definitive estimate. The only way to improve estimation is to learn from experience. Compare your estimates to actual results. How close were you? Calculate accuracy metrics. What percentage of estimates were within 10% of actual, within 25%? Look for systematic biases. Do you always underestimate testing? Do you always overestimate documentation? Understanding your patterns helps you correct them. Build an organizational database of estimates and actuals. Over time, this becomes invaluable for analogous estimation and calibrating parametric models. Let me warn you about common mistakes. Estimating in isolation without involving the team leads to estimates that those doing the work don't believe in. Ignoring historical data means repeating past mistakes. Your organization has estimation data, use it. Padding estimates secretly destroys trust. When discovered, and it usually is, your credibility suffers. Instead, use explicit contingency that's visible and justified. Accepting unrealistic dates without discussion makes you complicit in setting up the project for failure. Push back, negotiate, document. Let's practice. Think of a recent task, either at work or in personal life, that took longer than expected, maybe a home project or a work assignment. Now think back to before you started. What would a 3-point estimate have looked like? What was your optimistic scenario? What was truly realistic? What was the pessimistic case? Would the actual time fall within that range? This exercise helps you calibrate your estimation instincts and appreciate the value of ranges over single points. Let's summarize. Using multiple estimation techniques and involving multiple experts reduces individual bias. 3-point estimation with the PERT formula captures uncertainty explicitly rather than hiding it. Contingency and management reserves protect against known risks and unknown unknowns. And progressive elaboration acknowledges that estimates improve as you learn more. Early rough estimates give way to refined definitive estimates. In our next lecture, we'll explore the critical path method. You'll learn how to identify which tasks actually drive your project timeline and which have flexibility. We'll make it visual and practical without the math anxiety that often accompanies CPM discussions. Thank you for tackling estimation with me. It's uncomfortable, but it's essential. With the right techniques and honest communication, you can estimate responsibly even when no one truly knows the answer. I'll see you in the next lecture. Research is hard, but your tools should not be. Subthesis.com is the free alternative to expensive software. Whether you need to calculate Cronbach's alpha or organize your field notes, Subthesis has a tool for it. No paywalls and no registration required. Check the link in the description and let's dive into today's lesson.